Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating project, building a database from scratch in a mere 3,000 lines of code. Amazing, right?
Totally amazing. I've always been curious about the inner workings of databases. The idea of building one with zero dependencies is incredibly appealing. What's the core philosophy behind this project?
The core idea is to demystify database architecture by focusing on fundamental concepts. Instead of getting bogged down in massive codebases, the author breaks down the process into manageable steps, each building upon the previous one. It's all about incremental development, you know?
I see. So it's not about creating a production-ready database, but rather understanding the underlying principles?
Exactly. It's a learning exercise. The author starts with the absolute basics: power loss atomicity. This is crucial, ensuring data integrity, even in case of unexpected crashes. This is achieved using an append-only log with checksums. Clever!
Brilliant! Append-only makes perfect sense for data durability. But how does one handle searching efficiently in an append-only log?
That's where data structures come in. The author implements a copy-on-write B+ tree. This allows for efficient searching while maintaining the append-only property. It's a bit like version control for your data structure. Updates create new nodes instead of overwriting existing ones.
Interesting. So no overwriting, just appending. But what about space management? An append-only approach could lead to wasted space, right?
You're right. To address that, a free list is implemented to recycle unused B+ tree nodes. It's a simple yet effective way to manage storage efficiently. It's all about resource management, you know?
Got it. So from a simple append-only KV store, it progresses to a more complex system. How does it handle relational aspects?
The author cleverly builds relational capabilities on top of the KV store. Records are encoded as key-value pairs, and range queries and secondary indexes are added. It's a layered approach, building complexity incrementally. Ingenious!
And concurrency. How does it handle multiple simultaneous operations?
The copy-on-write B+ tree provides snapshot isolation for readers, meaning readers aren't blocked by writers. For writers, it uses transactional concurrency control, merging updates at the end of transactions. It's a surprisingly elegant solution.
Impressive. And finally, the SQL-like query language. How complex is that implementation?
The query language is relatively simple, focusing on basic point and range queries. It's not a full-fledged SQL implementation, but it demonstrates the core principles of query processing. The author even mentions that parsing the SQL-like syntax leverages compiler techniques, highlighting the interconnectedness of different software domains.
Fascinating. This project really showcases the power of breaking down complex problems into smaller, manageable pieces. It's a great example of how to learn by doing.
Absolutely. The entire project is documented in a book, making it an excellent resource for anyone wanting to delve into database internals. It's a testament to the fact that even seemingly complex systems can be understood and built with a focused, incremental approach. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into building your own database. Goodbye.
Bye-bye.